composition, we need these skills. So who can remind us, if I find f of -2, what does that tell us to do?
Substitute.
What was that, you sir?
Substitute x.
Amazing. Substitute -2 for x. So for today and moving forward, a very, very, very crucial skill when you substitute, when you plug in a value for x, a value, an expression, anything, what should we put around it?
Parentheses.
Yes, yes. So this would end up being -2 squared plus 10. Without those parentheses, you might just write minus to -2, which would just turn it positive, and that would change the value of the expression. So knowing that, what do I know -2 squared to be?
4.
4. So this would become 4, but hey, it's the opposite of 4 plus 10, which I know would give me 6. So a lot of you guys haven't, used this new calculator a lot. And with it, when you're squaring a negative value, you have to be smarter than the calculator, meaning the calculator is going to read -2 squared as the following. It's reading it negative of 2 squared. So if you input that into your calculator, it's just going to say -4. But how you want that to be evaluated is what you wrote down with the parentheses -2 all squared. This says, hey, take my value of -2 and square it. What does it mean to square something?
Multiply it by itself.
Great job. To multiply by itself. So that would be -2 times -2, which would be +4. So while you're working with the calculator, this is going to be top 3, one of the mistakes you're going to make on your test next week. So, you know how sometimes we like to just confirm everything with our calculator, right? 3 times what? Let me just make sure that actually is 3, like it didn't change on me. You know how you guys do that? Yeah, you do that. So, if you are to do that with your calculator, take a moment to reflect. Does that make sense? What were you trying to say? Oh, I was trying to say -2 times -2, that should be +4. Next up with our table, finding f of 4. What does 4 represent? What value? X value. So if I go to where is x4 here, what's the output?
7.
Great job. So all I want for you to say the output is equal to 7. On your quiz, girls listening back there, on your quiz I did not take off. A lot of you guys are writing it as an ordered pair 4, 7. It's just a little redundant. You don't need to do that. That's just already saying, I already said, hey, my x value is 4 here, and you're just repeating it over again. You don't need to do that. We just want the output there, which is 7. Same thing over here, f of 3. Our x value is 3. What's the output?
4.
There we go. All right, guys, so here's what our topic is for the day. It's on composition of functions. So this kind of looks a little crazy, right? Lots of different new notation here. I think what everybody should definitely write down for this slide here is to know that these two things are the same. And what do these two things say? So this is kind of new notation for us. If I just have this, how do you say that in words?
F of x.
F of x. Great. So thinking about those parentheses kind of like of. So if I'm reading this, this says f of g of x. And that's how we say that in words mathematically, right? We're all little mathematicians in here. So we're not going to say it as fog times x. So that's not what this is here. This is f. The open circle means of. So this means of g parenthesis of x. So your open circle means of. What if I had a closed circle? What would that mean to do instead?
Not of.
what operation in math?
Multiplication.
Yeah, that would just mean to multiply. So, what does f of g of x say to do? Normally we do have f of x. X represents our what? Our input values. Now notice what's in here instead of x. It's a g of x function. So this says g of x is the input into the f function. So g of x is the input into the f function. You're always going to work kind of like inside out, meaning you'll kind of start off doing whatever the g of x situation might be. Maybe it's just the whole function, maybe there's a value here. You'll apply that, then those results to f. So, let's say it all together. How do we say this? F of g of x. Beautiful. Don't ask me for help and say, can you help me find fog?
Yeah.
Yep, the open circle means of. So, take a second and jot down the f of x is 2x minus 8, and g of x is negative x plus 8. We are going to use those functions in a lot of different examples throughout today. I will add 2 more, but just kind of know if you write it down, kind of, now you don't have to keep writing it over and over again. So our first example wants us to find, kind of reading along, here's what we have, g of f of 1/2. So like I said, go from your inside out. So if I'm all the way inside, I have f of 1/2. That's my first step for me to do. And what did you guys say during the warm-up? How do I find f of 1/2?
Substitute for a.
Substitute it for x into the f function. So I have 2, remember parentheses, 1/2 minus 8.
Oh, it's 2x.
So what do I know f of 1/2 would be equal to? 1 minus 8, which would be negative 7.
Put that in g.
So what happened here? F of 1/2 is equal to negative 7, which now basically tells me, oh, now I'm finding g of negative 7. So I'm going to take my g function, and now I want to find g of negative 7. Same idea, I'm going to plug in and use parentheses around my values I do to figure out what that will equal. And well, that simplifies too. There we go. So, all together, g of f of 1/2 is equivalent to 15. And if you're a little lazy like me, you might kind of think about it like f of 1/2, oh, that was negative 7. So then you're just like, g of negative 7 is really what we did there. What questions do you guys have here?
If we were to just put like g.
Huh?
If we were to just put like g of negative 7 equals 13 on a test, would you accept that?
Sure, if you show me how you got negative 7. The deal with your test, and I'll repeat this before you take your test too, is the more work you show, the more you're going to help yourself, because I can award you like partial credit along the way. If you just put like 12 as the final answer here with no work, you'd get like no points whatsoever. So
Even if you get it right?
So getting the question right is only like 1 point. You have to show different steps along the way. You know what I mean?
Oh, okay.
Right. You guys don't need to jot this one down, but we can just kind of look and work through it together because, you know, it's a lot of stuff to write down with the tables. So let's go from our inside out. We want to find g of f of 1, meaning first step all the way inside is f of 1. So going to my f function, my x is 1. What's the output here? 4. So basically, huh?
How's it 4?
X is 1, output is 4.
Oh, okay.
Yep. So now I'm going to take my g function, and what's the x value for my g function?
4.
4. And then what's the output?
3.
Great job. So g of
Oh,
f
that's so easy.
of 1 is equal to 3.
Is
I
this
think,
on our homework?
yes.
Wait, so can we do that part of the homework now?
Like not right now because we're in the middle of a lesson,
not
but
right now, but-
at the end of class, yes.
Like at home, that's what
Mhm. And at the end of class, you guys should have like 20 minutes or so. All right, last little like level 1 question. So, kind of thinking about Jaden's question of what being on the homework, I would say these are probably like, you know, a little easier parts for your homework, and then we'll ramp it up a little bit. We want to find g of f of -2. So if I ever have it in this notation, I always take a second and rewrite it as g of f of -2. I think it kind of tells you a little bit more clearly about what to do. Yep, our first step is f of -2. So looking at your f function, what's f of -2?
1.
Great, my output is 1 when my x is -2. So now I want to find g of 1. And what would g of 1 be equal to? There we go.
Yeah.
So, g of f of -2 is equal to 2. Alright, so what questions do you guys have here? Just kind of like basics, table, graph, evaluating.
Can this stack, can it be like f of g of h of x?
Yeah, you can do 3 or more. You can do as many, right, as you might want. All right, so what do you guys already have written down? You already have your f function written down. You already have your g function written down. Let's take a minute, write down the p function and the r function, and then we'll go through these together as, you know, as you'll notice, you're not evaluating anymore. As in evaluating with just numbers. We're going to be more simplifying now. All right, so first up we have f of g of x. So look at what we have here. Also, if you're a pretty visual person, I do think having a different colored pen or a highlighter can help too. Remember, we're going from our inside out. So g of x is now your input, and you're going to input g of x into the f function. So think about what is our f function. It's 2x minus 8. But instead of x, remember x represents your input. So instead of x, meaning I'm not using x as well, instead of x, I have a new input. And that input is my g of x function. And what's our g of x function? Negative x plus 8. So this is why those parentheses are so important here, everybody, because without it, you might not do like that algebraic simplification correctly. Those parentheses really cue us what to do next. And what do you see? What's it telling us to do? Distribute, right? That 2 outside of your parentheses is going to tell us to distribute. So I'd have negative 2x plus 16 minus 8. Oh, right. Algebra. We remember that. So keep going. What do I have to do next?
Minus 8.
Yeah, so 16 minus 8. So I'd end up with negative 2x plus 8. So combining those like terms after we multiply through. And that would be f of g of x. So next up we have r of p of x. So like I said, I was taking an extra second and rewrite it as r of p of x in that format. And looking at what we have, all the way inside, that's our input, p of x. and I'm going to input it into the R function. So kind of think about what do we have here? P of x is x minus 4, and everywhere I see x, I'm going to replace it with x minus 4. Kind of think about what we have going on. Instead of x, I'm going to replace it with x minus 4. Yep, so it's x minus 4 all squared, because that's what R of x tells us to do. And then it's going to be 2 times an x plus 1. But instead of x, we use the p of x function, which is x minus 4. And now, algebraically, what is this kind of telling us to do next? Distribute. Well, notice we have an exponent, right? So everybody see an exponent somewhere? Yeah, let's tackle that first, right? So if I have x minus 4 all squared, what does that mean?
Square the x and square the negative 4.
Oh, not quite. What does it mean to square something?
Oh, multiply by.
Multiply by itself. So
You would do x minus 4 times x minus 4.
yes, and you know what? If you do x minus 4 times an x minus 4,
You can factor it.
not
Foil.
foil. Yes, good job, guys. Because if you're just writing x squared plus 16, that is without a doubt my biggest pet peeve in algebra. Because you're not actually squaring that binomial. Binomial means there's 2 terms here. So to square binomial means to multiply it by itself. And yes, that's where our next idea of foiling, which means to multiply binomial times binomial. Or if you like that box method, you can also write out a box to help you multiply it through. You'll end up with x squared minus 4x, another minus 4x, and plus 16. And everybody for,
X
you know,
squared plus 6.
and then for a couple months right now, until I show you a little shortcut, take that, multiply it by itself, so that way you don't get yourself into any trouble and you're able to square that binomial. One more step here. What do you see, Jaden?
X squared minus 8x plus 16.
Great job. Combining those like terms in the middle. But that was just this first part here. Now thinking about what we have left. We have to distribute the 2. So now we'll have plus 2x minus 8. And then lastly, plus 1 to bring on down. And why don't you guys take a minute and combine those like terms on your own, and we'll check to see what you got. All right, you guys, what did you find that to equal after you combine your like terms? What did you find, Yusra?
X squared minus 6x plus 9.
Great job. So that is R of P of X. Good. And think about this question, everybody. We had to show compositions. We had to do a lot of good algebra skills. We had to square a binomial. We had to multiply it through with that FOIL idea. We had to distribute. We had to combine like terms. You know what that sounds like to me? That sounds like such a good type of question you might see on your test next week, right? Thinking about all those different skills that this assesses. So take the hint as you will. Yes, yes. What other questions do you guys have here? All right, you guys try the next two. So notice F, G, P, and R are still the same, so you don't need to keep jotting them down. But notice your questions that are being asked are different. This is G of F of X. Not the same thing.
It Oh,
as f of g of x.
Is it the same number?
It's the same functions, I just said that. What I can tell is if you struggled with the first one at all, you forgot those parentheses here, so you didn't distribute that negative to both terms. And if you are someone who really likes to write that one in front of your parentheses to help you with the distribution, go for it, do that. We're going to walk through the second one together, which says P of R of 2x. So going from your inside out, meaning R of 2x is what you want to do first. So go to your R function, here it is, and instead of x, I'm going to replace it with 2x. And every time I replace, what should I put around my value? Great job. So if you do that, you'll be good to go. So think about instead of x, it's going to become 2x. I'm going to square that. What? And then instead of x, once again, it's now 2x, and I'm going to add 1. So just doing our algebra, right? 2x all squared. What does that become? How do I square something? It means multiply it by itself. So 2x times 2x is going to become 4x squared. Good job. What about 2 times 2x? That would just be 4x. And then plus 1. And are any of these like terms to combine?
No.
No. Good job. So think about what does my problem say? P of R of 2x. I just did R of 2x. Now I want to take this and input it into the into the P function instead of x. Now what does my P function say? It says hey, take R of 2x, which is this, and then what am I doing after? I'm subtracting 4. So notice there's no value in front of the parentheses here, so nothing to distribute. So P of R of 2x would just become 4x squared plus 4x, and then lastly combining those like terms for minus 3.
Oh,
Of course. Alright guys, so once again, another good like test level question, right? Think about you're showing composition, showing some good algebra skills to help you simplify for your final answer. What other questions do you guys have here? Alright, next up we're going to do some operations with our compositions. You guys don't really need to write anything down on the next slide. I'm just going to kind of talk about it for a brief sec, and then we'll do some more operations with, once again, the same F, G, P, and R functions. So, for your operations, you just kind of look in between your functions to see the operation. So notice here we have f plus g of x, meaning take f of x, add it to g of x, right? Here's my addition symbol. So that just tells me add the two functions together. Next up here I have f over g of 2. Notice here my value 2 means, hey, I'm going to input 2 into the f function and into the g function. My operation is division here. So let's do some examples. So once again, you have all of these guys already written down. First up, what operation do you guys see in between f and g here? Multiplication. So this is the same thing as f of x times g of x. So I'm going to take my two functions and multiply them together. So I have 2x minus 8 times negative x plus 8. And what symbol should I use to help with that multiplication? Should I just put a dot in between them, or what do we think? Parentheses. Parentheses is probably going to help you multiply those through so you don't forget any terms, because multiplying it through is just doing what? We've talked about it already today.
Foil.
Yeah, that idea of FOIL. So I'm going to give you guys a minute to complete this problem out on your own. Multiply it through. If you like the idea of FOIL, do that. If you like the box method, go do that. Whatever's, your jam. You do what you do you. Alright guys, so check your work on the board. You would end up with negative 2x squared plus 24x minus 64. Now, looking at our next problem, we have r minus p of negative 1, which means the same thing as r of negative 1 minus p of negative 1. So what do we need to find for both of those?
-1.
Yeah, you need to input negative 1. So let's find p of negative 1 and r of negative 1. Why don't you guys take a minute to try to find those two values on your own. Alright, so p of negative 1, negative 5. What about r of negative 1? What did you guys find that to equal? So don't forget that negative 1, parentheses around it when you square it. So you'd have 1 minus 2 plus 1, which would give you what value? 0. So r of negative 1 is going to equal 0. So your problem says r of negative 1, which we know was 0, minus p of negative 1, which is negative 5. So 0 minus negative 5 will give us what for our final answer?
5.
There we go. What questions do you guys have before you try a couple on your own? All right, let's do it. You need another second? Okay, if you need another second, the work's still on the board, but notice now the problems are different. So your first one is g minus f of x and p times r of 2. You good, Nathan? All right. All right, guys, so check in with the solutions on the board. So g minus f of x, if you did not end up with negative 3x plus 16 as your final answer, here's what I know you probably did. You probably forgot those parentheses here. So what this says is to subtract the whole function. So think about this is the same thing as g of x minus f of x. So this is how you take the whole g function and now subtract that whole f function. And when I want to make sure I subtract the whole function, put parentheses around it. Your next question said, hey, do p of 2 and multiply it by r of 2. So plugging in 2 for both, multiplying it together, you'll get negative 18. What questions do you guys have here before we have the very last little bit of new information? So, same thing. Like if this was a division symbol, you just have negative 2 over 9 instead. Alright guys, so who remembers what did we talk about last time? Anybody remember? What idea did we talk about last time? What do you remember, James?
Inverses.
Inverses. So compositions of functions are crucial to proving if two functions are inverses. So kind of like a proof in geometry, except it's not going to be like step-by-step justification. It's more so of like, in order to prove things are inverses, if you find f of g of x to simplify just to x, and also g of f of x to simplify just to x. Therefore, they will be inverses. So that's totally different than what you did last time. Last time you started off with one function and you found its inverse. Now we're saying, hey, you're given two functions, right? You're given this f function and this g function. Prove that they are, in fact, inverses. So kind of think about why that would make sense. They're going to simplify to just x because if you were composing one function inside the other, you're going to find opposite operations going on, meaning you'd probably have a plus 5 somewhere and then a minus 5. 5 minus 5 would end up just simplifying to 0. So then you'd just be left with x. Same thing if you had like a 2x that you're multiplying that x by 2, but then you had somewhere else where you're dividing by 2, and you'd simplify just to x. So you'll have to do both to make sure they are, in fact, inverses. Give you guys a couple more seconds to jot down this idea, and then we'll do 2 more examples. Alright, so here we have f of x equals x squared minus 1, and g of x is the square root of x plus 1. We want to determine if they are inverses using compositions, which means we have to find first f of g of x. So to find f of g of x, I'm going to take my inside function, which is g of x, and I'm going to input it into my f function. So instead of x, I'll input the g function, which is the square root of x plus 1.
So, is it if you get 0, is it an inverse?
Not 0x.
If you get x, is it an inverse?
Yeah, so let's see what happens.
Also, then these are inverse.
So if I have the square root of x plus 1 and all of that squared, what happens if I square a square root? Yes, because guess what? They're inverse operations. So I have x plus 1 minus 1. It's like that sneeze is contagious. Whew. So lastly, what is f of g of x going to simplify to? Just x. Is that what we want?
Yeah.
Cool, so that we're done?
Yeah.
Nah.
No. I thought you said
All
to
the
get
extra. No.
You have to always find g of f of x as well. So thinking about g of f of x means f of x is my input function. So instead of x, I'm going to now replace it with the f function, which is x squared minus 1. And square roots are similar to parentheses, meaning simplify under there first. So x squared minus 1 plus 1 would just simplify to x squared. So at the square root of x squared, what happens there? It's just x. So g of f of x also equals just x.
So you're done now?
I'm done, but what do I know? What does this show me?
They're inverses.
Yes, they
Also, you
are
have to do both
inverses.
sides for it to be inverse?
Yes, you do. Because both of those equal x. So, yes, both of these equal x. They are inverses. What do you guys remember about being an inverse graphically? Anybody remember from last time? What do you remember, Yusra?
They reflect over the line y equals x.
Amazing. They reflect over y equals x. So let's look at what we got going on here. We have x squared minus 1 in red, and then we have the square root of x plus 1 in blue. And we have the line y equals x in green. Does it look like blue and red are reflecting over each other?
Yeah, but if you're looking on y equals x and you cut off part of the red, it is reflecting over each other.
That's a great idea by Chloe. It's only reflecting if you cut off part of the red. Cutting off part of the red is what we like to say mathematically as called restricting your domain. So this is something we'll do when we get into quadratics, but I just wanted to give you guys a little preview. So I want to restrict my domain, meaning my original function and its inverse, the domain and the range are going to be swapped. So if I want to restrict the domain of the red function, it's going to come from the what of the blue function? The range. So look at the range of the blue function. Where does my range start? At what value? 0, and it goes until infinity. So that's what I want to make the x value here. I want my x to be starting at or equal to 0 and going to infinity. And now after I, in closed terms, cut off part of the red, does it look like it reflects? Yeah, cool, good. So that's just a little preview of something we'll get into later on. But what other questions do you guys have here? All right, final example for you guys to try. Try this, and then I'll post the solution, and then after that, I'll let you know what you're doing from here. Are you guys still listening? Check your solution here. You should see f of g of x simplifies to x, and g of f of x also simplifies to x. So if both of those simplify to x, what do we know?
Inverses.
Yes, they are both inverses. So if you remember last time, you kind of looked at different operations to see if what was going on was the opposite. But noticing here, it wouldn't have been the case, right? I had a minus 12 and then a plus 4. So, just so you know, doing those compositions to prove it for sure. You guys okay over there? Mm-hmm.